Finally, let's talk about some common graphs we see in scientific publications, especially those in behavioral sciences journals. Let's cruise all the way down to the bottom here, right about here. A couple graphs right off the bat. The first is a bar graph. This looks very similar to a histogram, but it's easier to make than a histogram. You don't have to deal with upper real limits and making sure you have those in your intervals. Instead, you can just have data points and it makes these bars. Notice the bars aren't touching. This is a very common graph that we see. It's called a bar graph. So typically you have the independent variable on the x-axis and the dependent variable on the y-axis. These are also categories, and so they lend themselves to bars. As opposed to here, this is called a line graph, and again, similar to a polygon, but it doesn't touch the x-axis at either the beginning or the ending point. But line graphs are very common in scientific journals as well. We use line graphs instead of bar graphs when the data seems to be continuous. So this is number of words. Even though these are categories, it logically sense that they move in order from 0 to 5 to 10 to 15. So a line graph is more important. Once again, independent variable on the x-axis, dependent variable on the y-axis. Finally, a graph we're going to talk about in Lesson 7, in the second third of the course, is called a scatter plot. A graph that I think has the most perfect name. So this is what we use when we conduct correlation data, where we have two data points from one individual, say a person's height and weight. And it's one point represents those two values. And there's a scattering of points. This data right here looks like there is no relationship between these variables. If there was a relationship, you would see a straight line of data. We'll talk about that more in Lesson 7.